different concepts from an algebra standpoint, so he kind of expects that you have some understanding of something called slope-intercept form. Does that ring a bell? So when I say slope-intercept form, what comes to your mind? Okay. So we do have some exposure and some experience with algebra. Now, that's a wonderful way to be able to graph a problem because it tells you what the slope is, how steep the line happens to be, whether it's increasing or decreasing, and it also tells you where it crosses the y-axis. Two important pieces of information for us to be able to graph an exercise if we like doing tables of values. And I would probably, if I had to guess, I would say that probably 80% of you, if I gave you an equation to graph, would probably want to graph it using a table of values. But I'm going to present maybe a different way of looking at things as well. So we understand a little bit about slope-intercept. We know slope is the numeric measure that we give that describes how steep the line is. And we know that positively sloped lines will always give us a visual of running uphill as we go left to right. That negative slope lines will always give us the illusion of running downhill as we go left to right, since that's the way that we read. That when we have a zero slope, that we're going to have a horizontal line, and all horizontal lines will go through the y-axis. And that we have vertical lines, which have an undefined slope, always go through the x-axis. So they may ask you some questions about which of these is a positively sloped line, which of these is a negatively sloped line, which of these has an undefined slope, which of these has a zero slope. And they're not asking you to identify what the slope is, but they're saying they don't know what you're going to be doing when you start solving the problems. So if you're trying to solve them by hand, then maybe some of those skills are going to have to come back somewhere along the line. So just kind of a vocabulary type of concept that sits out there. This is a typical type of problem that we're going to see when they ask us to solve by graphing. They're going to want us to put that equation, those two equations, on the graph at the same time and find out what the point that they share in common happens to be. So let's cater to you first. How are you more than likely going to solve this problem? Maybe you're going to go back to the slope-intercept form, right? They're not in the right form yet, are they? Having the slope-intercept form means you need to do some transformation to the problem to get the y value alone. Some of the questions may give you a problem like the first part of that and say, change this and solve for y. In other words, change it to slope-intercept form. Why are they doing that? Because some of you will use that technique, and some of you will use a different technique. So if that was the case, and I was doing this particular problem, let me move, oops, I didn't want to do that. Hang on a second. Let me move this out of the way for a second. You'd take that first equation, and you would probably do some transforming by saying that 2x plus y is equal to 8. You would want to get the y value alone. And if you wanted to get the y value alone, you would end up doing what? So you would subtract the 2x from this side, and you would subtract the 2x from that side. You'd be left with y alone on the left-hand side. And on the right-hand side, you'd have a choice of whether you wanted to write negative 2x plus 8, or whether you wanted to write 8 minus 2x. And it really doesn't make a difference for computation in a problem. What makes a difference is that you have the signs in the right place. So you've got to be careful about that. Now, once you have that, you would probably proceed to a table of values. Agree? You would choose x values, and you would substitute those respective values of x in and find out what their partner value of y would be. Correct? So where do you want to start? 0? You and I are going to be friends. I like zeros. Zeros are real nice for graphing, because a value that has either an x or a y component that's 0 is on the axis, and it's an easy point to graph. So if I have an x value equal to 0, then that means that my y value is going to be 2 times that 0 value minus 2 times that 0 value plus 8, which means I'm going to come up with a value of a nice 8. So my ordered pair value here is going to be an ordered pair which would have x equals 0 and a y value of 8. That I know has to be on the line. The graphs you get online are going to have scales on them already. The graphs in the workbook don't have scales on them, so you got to decide what you want each one of the blocks to represent and be uniform with it. But if each one of these blocks represented 1 unit, then 0 and 8 would be a value that I would position right up there. We graph x values horizontally, we graph y values vertically. Some of this coming back, sounding familiar? Not boring you too much, okay? Because it's going to pick up somewhere along the line. Now I need a second point. 1. So that means that I now take a negative 2 times 1 and I add 8, and I'm going to come up with a value there that's going to be 6. So now the second point that I have is a 1 and a 6 value of the problem. Well, if x is 1 and y is 6, then this would be the second point that I have to hit. And I would probably connect the dots by drawing a straight line through those points. Now, here's another reason why we don't necessarily like to do it by hand, because when you draw straight lines, some of us don't use rulers, and we guess where the straight line is going to be. And if that line has just a little bit of wobble or variation to it, then it may impact your ability to read where the two lines cross one another because you were a little bit sloppy, making graphing not necessarily reliable by hand. On the program, very reliable, but still no promise it's going to be an intersection, it's a nice whole number. Okay, so second verse, same as the first. We take the second equation now, 4x minus y is equal to 4, and you need to solve for y as well. So what's your first step?
Add 4x to both sides.
I've already got a positive 4x.
Subtract
So adding 4x to both sides isn't going to get rid of the x on the left-hand side.
Subtract 4x.
Subtract 4x from both sides of the problem. But now when you subtract 4x, this poses a little bit of a problem because it leaves that negative coefficient on the y term that's going to have to be stripped off somewhere. So once again, minus 4x plus 4, or we could have 4 minus 4x, it wouldn't make a difference. But now we have to divide everything in the problem by that negative 1 to strip the coefficient off of the x term of the problem, which leaves us a nice positive y, and it turns this into a positive 4x, but it turns this into a negative 4. And then you would end up doing, very likely, the same thing. You'd have a table of values where you'd pick x and you'd find out what the values of y are. So let's say that you're going to be consistent and you're going to use an x value of 0. So we know that 4 times 0 leaves us a value of 0, and 0 minus 4 has to leave us with a negative 4. So one of our points is 0 and a negative 4. Well, 0 and a negative 4 is an easy point to be able to graph, right there. And then, what do you want next? 1, fine. So 4 times the value of 1 minus 4 gives us a value of 0. So now we have a 1, 0 that we're going to graph. And 1, 0 ends up being right here. And now if I connect the dots with those, what I'm hoping for is if this is a consistent system, that those lines will intersect one another. And if I haven't been careful graphing, they may not actually hit one another in a point that's sitting on a corner, which means that I could have been sloppy in graphing, or the solution to the system wasn't whole numbers, was fractions, making it tedious to do. But that's what I would expect might be seen if you're doing a problem by hand. Now, I want to introduce something that might be a little bit different. I want to come back here and take this particular slide and I want to clone it or copy it. And I want to show a slightly different approach of what we might do in an exercise. I don't want transparency, I want eraser. And I want big eraser. I'm not going to change those graphs.